Good afternoon, everyone. Welcome to the talk, The Website's Down, Stories and Lessons on How to Keep Your Website Up. My name is Adrian Ubalde, and I'm a site reliability engineer for the property website Domain. So I'm going to start off by talking about a particularly stressful, exciting time at Domain earlier this February, where the website went down a handful of times in that 1 week, a period I now refer to as Hell Week. And then I'm going to talk about how we faced those challenges and had to figure out how to improve our current website in terms of reliability and resilience to failure, and how we were able to apply those lessons to applications that we would build from now on. So Hell Week, let's just say it was a really bad time in terms of availability. The website went down on 3 separate days in the space of that 1 week. So we had a brilliant start to the week with our first outage around 14 minutes that Monday evening. Thankfully, we were able to bring the site back online by simply resetting our web servers. And afterwards, after looking through our logs and looking at all the system health data for our various backend APIs, one of which is a Redis cluster that we use for storing user session data, we were, being a pretty high traffic website, we were expecting to see quite a lot of traffic to the Redis cluster. We get upwards of 1,000 user sessions during peak time. But after looking at the data, we noticed an abnormally high spike in CPU and read requests. So our hypothesis was that there was a problem with how our website was using our Redis cluster for session state. So unfortunately, just 2 days later, we had our next outage, but unfortunately, no amount of resetting our web servers was bringing back our website online, at least not in a stable way for more than a few minutes. In fact, we had a total of 21 outages in that one afternoon for a total of about an hour of downtime. So we had an emergency meeting that afternoon where we came together to diagnose those outages and try to figure out a way to stabilize our website. And after going through the various options we had, we decided that we would replace our Redis session store with a DynamoDB managed service session store. And in the meantime, while we were developing that code change, we were going to switch over to an in-process memory session store. And thankfully, that brought back our website and stabilized it. And after about an hour, after we'd finished the code change, we switched just 2 of our servers over to DynamoDB and crossed our fingers, and thankfully our website remained stable. And up at about this time of that day, it was about 9:30, so we decided, all right, we're just going to leave it as is and monitor it overnight. And then the next morning, we switched all our servers over to DynamoDB. So all was good until 2 days later. We had our final outage of that week. Like the previous incidents, we saw a dramatic spike in the number of read requests to our session store. So that's when we decided we'd just switch over to a pure in-memory session store mode. And then we'd go through our website functionality and just try to remove or at least refactor anywhere we relied on session state. So now that we came out of that week of outages, we now had the chance to step back and look for ways that we could improve our website in terms of reliability and resilience to failure, but not just our current website, but any of the applications would be building from now on. But as part of that, we wanted to also evaluate how well we did in terms of reacting and handling those outages during that week. And one of the biggest challenges was how hard it was to quickly and effectively go through our log files. And one of the challenges was that we just had all these log files spread across all our servers. Another challenge was that not all our developers had access to our logs. And once you had your hands on those logs, searching and sorting and filtering through those logs was really cumbersome with the tool set that we had. So that's when we decided we'd start looking into Amazon Elasticsearch's managed service as a way of addressing these problems. So we started writing our application logs and our incoming traffic logs to an Elasticsearch DB. And that replaced the need for us to have to search across multiple log files, spread across multiple servers, and instead be able to search, sort, and filter from a central location using a user interface that both our developers and our DevOps teams could both access. And by using Kibana, which comes out of the box, with Amazon Elasticsearch's managed service, we could filter easily by time, by selecting the right bar or a period of time in that section. If you wanted to, you could sort by a particular piece of log data. So for example, if you wanted to find out what the slowest endpoints in your application were, then you could sort by time taken in descending order. And finally, you could also easily filter your logs by using Elasticsearch's querying capabilities. The problem was, when we went with this logging solution, we ran into out-of-disk space issues earlier on because we weren't entirely sure how much space we needed to store all that data. It was ideally we wanted to store at least a couple of weeks worth of data so we could do week-to-week comparisons. So to get around that, we started by fixing the most commonly occurring errors, and that saved a significant amount of disk space. And the second thing we did was reduce the number of data nodes in our Elasticsearch cluster from 2 to 1, effectively removing replication. So although we traded off having a redundant copy of our logs and some search throughput and performance, we effectively halved the amount of disk space that we required for storing our logs. So now we had a better way of a more quick way of analyzing our logs. But the thing was, we still didn't know exactly what had caused those outages during that week. Even after spending quite a bit of time poring over our logs and looking at the system health data for clues. So what do you do when you're not entirely sure what the problem is? So what we did, we took a step back and looked at the problem by starting with what we had in place. So we had an ASP.NET application deployed across a load balanced set of servers, which called out to a handful of APIs. And our application was proxied by a CDN. And by looking at this, we asked ourselves, was there a way to protect our end users from an outage in our ASP.NET application? And that's when we started wondering what role our CDN could play in giving us this insurance policy. So first of all, what's a CDN? CDN is basically a proxy that sits in between your end users and your backend application. A CDN has the ability to cache resources like HTML, JavaScript images, CSS, which comes in really handy in the event that your backend application goes down your CDN is able to offload traffic from your backend application. And as an example, we had a breaking change to one of the microservices that powers our property details page on domain, where there was an update to the data returned from the microservice back to our website in a way that it broke its data contract between the two. So how did that look? End user makes a request to a property details page, which gets handled by the CDN. CDN makes a call out to our website. Our website then calls our microservice for property details data, which returns a JSON response, which no longer adheres to its data contract with the website. Website generates an error. Upon seeing that error, the CDN will check if it's got a cached copy of that requested page from a previous request, and if it does, then it will return a successful response back to the user. So that's great. And this number, roughly 400,000, is the number of successful property details page views that would have otherwise been error pages if it hadn't been for the offloading and the caching that we'd set up in our CDN. So great, now we have a more effective way of analyzing our logs so we could more quickly react to outages. We had a way of protecting our end users from a back-end application outage. But how could we improve the resiliency and the reliability of any new applications that we would build from then on? So not long after those outages of that week, we began the rebuild of our homepage. And with resilience as a top priority, we began by asking ourselves a couple of basic questions. First of all, what could go wrong? And then second of all, what happens if X, Y, or Z goes wrong? So we began by looking at what we had already in place. You've already seen this. We have an ASP.NET application deployed to multiple load balance servers, calling out to a handful of APIs, and we are proxied by a CDN. So it's quite clear to see from this picture there are quite a few things that could go wrong. Each of those calls to those APIs is a potential point of failure. So in the new design, we decided that we would pre-generate the HTML for our homepage. We'd host it in an AWS S3 bucket, which is basically a static file hosting service. It's got virtually a 100% uptime SLA. It stores redundant copies of your files across multiple data facilities and within each of those facilities across multiple devices. And it also auto-scales to handle incoming traffic. As another layer of redundancy, we also cache our homepage in our CDN for an hour. So if there's ever an outage with our backend application, or something else goes wrong with that connection, the end user could still see a cached copy of our homepage. As another layer of redundancy, we also cache our homepage in the end user's browser for an hour, so that in the event that we've misconfigured our CDN, for example, or the end user's having internet connectivity issues, as long as they've visited the website before, the homepage before, they should still be able to load up the homepage. So in our new design, end user makes a request for the homepage, which gets handled by our CDN. CDN makes a call to S3, which returns the pre-generated HTML, which goes back to the CDN where it's cached for an hour, which is then returned back to the end user where it's also cached for an hour. And so comparing the two, we've reduced the number of things that could go wrong by reducing the number of APIs that we depend on. And by reducing the number of APIs we depend on, we're also, as a bonus, improving the response time for loading up the homepage. And not long after we started the rebuild of our homepage, we also started the rebuild of our property details page. So like before, we asked ourselves the same questions. What could go wrong? And what happens if X, Y, or Z goes wrong? And like before, we looked at what we already had in place. Load balanced ASP.NET application calls out to some APIs, which is proxied by a CDN. Like before, a lot of things could go wrong. Each of those API calls is a potential point of failure. So in the new design, we've replaced that with a single call to a DynamoDB table, where we store all the listing data for all the listings across our site, which we pre-aggregated in a separate offline task. And because we're using DynamoDB, which is a managed service, it means that we don't have to spend as much time maintaining that infrastructure. It also lets us pre-provision its capacity according to our throughput needs. And like before in the homepage, now that we're just calling one API, we've also improved the response time for loading the page back to the end user. And we also decided that we would build a new front-end application for the property details page. And by doing that, we effectively built a bulkhead in our website, much like the bulkheads, those metal partitions you find that you could seal shut and use to divide your ship into separate watertight containers. So in order to basically contain the damage to one compartment and keep it from spreading to the rest of the ship, in our case, to the rest of the website. We don't only do that for the property details page. We do it across a lot of our website. The homepage, as an example, it's a pre-generated static homepage, HTML page, which is hosted in an S3 bucket. We also do it for our property profiles section of the website. We also do it for our search results page and our new homes page. So by having all these separate microsites, what that allows us to do is for the property details page, we could provision it and scale it independently of the other parts of the website. We could also release it independently. And this is one of the main ways that at Domain we're able to release as frequently as we do into production with minimal risk of a site-wide catastrophic failure. Another way we enforce damage containment is by using circuit breakers whenever we make an API call in our system. So the way circuit breakers work are that they sit between your upstream services and its clients. They start off in a closed state. Client makes a call to a service, and if the service returns an error, the circuit breaker keeps track of that error. And once the number of consecutive errors reaches a particular threshold, that's when the circuit breaker goes from a closed state to an open state for a predetermined amount of time, say a minute, during which any calls from the client to the service are automatically stopped. And what this does, it means that your struggling service is given time to either auto-correct or auto-heal itself, or it gives the development team that's responsible for that service time to manually intervene and diagnose and address the issue. And the final way that we enforce damage containment in our sites is by making sure we explicitly set timeouts whenever an API call is made. And what this means is any slow responding services don't result in downstream clients from having their outgoing request queues start to build up or other resources like memory to start maxing out. So great, we have a way of containing damage to a particular part of our website, and we also have a better way of doing log analysis. We have a way of protecting our end users from an outage from our backend application. One area I often see overlooked is making sure there's the right alerting put into place for a new application. So at Domain, we have a set of uptime targets and end user satisfaction targets based on response times. So we need a way of measuring how well we're doing and be notified of when we're starting to deviate from those targets. And we use a number of services for that. We use Pingdom to maintain a set of uptime checks against our various websites and against various endpoints within each of those websites. We also used New Relic to basically alert us about any errors or regressions in response times, stuff that our Pingdom alerts wouldn't tell us about. And we also use OpsGenie to make sure that our on-call engineer gets notified of production incidents direct to their phone. But one thing we wanted to make sure was that when we were setting those alert thresholds, that we don't set them too low. So in fact, drowning out our team with alerts every few minutes, which is a good way to have them completely ignored eventually when there's no real need for intervention. But you also don't want to set them too high because you might actually miss out on a genuine production incident. So we started off by setting them lower than usual and only having those alerts sent out to a handful of people, warning them, you're probably going to get more alerts than needed, and we're going to work on tweaking those thresholds as new traffic came in. Cool, so just a quick recap. I started off by telling the story of all those outages during Hell Week, how it forced us to figure out how to improve the way we do a log analysis so we could get to the root cause of a future outage, how we used our CDN to give us an insurance policy against another backend application outage. Then I talked about the rebuilding of our homepage and our property details page to be more resilient, basically by reducing the number of points of failure. And finally talked about the need for putting in the right amount of alerting and the tools that we use at Domain. And if you're interested in jumping into some of these topics a little bit more, like reliability and resilience, there's a couple of resources I highly recommend. The first one's a book called Release It, Design and Deploy Production-Ready Software. It was published quite a long time ago, but its content is still really applicable to today. And the second one is a website called highscalability.com, which has a lot of interesting case studies for real high-traffic websites that need to scale well and need to handle failures in production really well. So that brings us to the end of my talk. Thanks for listening. If there's any questions, happy to answer them.